In this last section, we are solving equations that involve inverse trig functions. They might have an inverse trig function written in the original problem, or we might be using inverse trig functions, which really we have been doing already. But we're kind of just putting things together here to solve for whatever is requested. Okay, so as a reminder, if we have a trig function, like in this case, sine of theta is equal to k, then to isolate theta, we need to undo the sign. Well, we undo the sign by applying the inverse sign. And if we apply the inverse sign, let me make this a little bit bigger. If we apply the inverse sign, we're doing that to both sides of the equation. Sine inverse of sine, those cancel each other out. We have theta by itself, and so that means that theta is equal to sine inverse of k. Or we could also write it is equal to arc sine of k. So once again, what we are looking at is we want to undo the sign, meaning we're going to take the arc sine of both sides of the equation, okay? And so this is how we would define or write our inverse trig function. If sine x is equal to y, then x is equal to sine inverse of y. And that is true for any of the 6 trig functions, not just sine. Okay, so let's do a couple examples. Here we are solving each equation for x. For these first two, let's see, for these first 4, we have y defined in terms of x. We want to solve for x, but it is going to be in terms of y. Now, it does say that we have an interval here. We don't really care about that interval as far as the solving process goes, but if you think back to what we did at the beginning of this chapter, we talked about how we had to limit the domain of the trig functions in order for them to be one-to-one. That's what these limits are. But again, it doesn't change the solving process. Okay, so I've got y equals 1/4 sine x. We're trying to undo what is being done to the x to get x by itself. So first thing I'm going to do is multiply both sides by 4. So then I have 4y is equal to sine of x. And then I'm going to take the arc sine, actually move that over, give myself room to write it, 4y equals sine of x. And then I'm going to take the arc sine, or the sine inverse of both sides of this equation. So then I have arc sine of 4y is equal to the arc sine of sine x, or inverse sine of sine x, which is just x. I isolated x. Again, this is solving for x in terms of y, so I am done. Okay, on this one right here, first thing I'm going to do is divide both sides by 3. Get rid of that. And then I need to do the inverse of cotangent. So arc cotangent or cotangent inverse, I'll write it with an inverse function this time. Cotangent inverse of both sides, so in cotangent inverse of y over 3 is equal to cotangent inverse of cotangent. So again, by taking the cotangent inverse of the whole thing, we are undoing this cotangent here. So I just have a 5x left over. Lastly, get x by itself, divide both sides by 5. So I get x equals 1/5 of cotangent inverse of y over 3. As a reminder, I cannot move coefficients in and out of trig functions or of inverse trig functions. So I can't, when I divide by 5, that doesn't become y over 15. Likewise, I can't change this to a y, just a y, and move the over 3 or the 1/3 to the outside, okay? The only way to change the angle or the ratio that is inside a trig or an inverse trig function is by using an identity, okay? Like switching from cosine of 2x to being 2 times, or I'm sorry, sine of 2x would be 2 times sine of x cosine x. That's the only way we can change what's inside the trig function. Okay. Next example, we have y equals 3 cosine x plus 4. Again, undoing things. Essentially, I'm going through the order of operations backwards here to isolate the x. So I'm going to start by subtracting 4 from both sides. Then I'm going to divide both sides by 3. And if you want to split that into y over 4 minus 4/3, or y over 3 minus 4/3, you can. And then I need to take the arc cosine of the entire equation. Sorry, I know that's kind of off the video there. There we go. Arc cosine of both sides, and so we have arc cosine of the whole quantity y minus 4 over 3 is equal to arc cosine of x is just x. Okay, and then last example here, I am undoing the tangent first because there's parentheses around the 2x minus 1, so I'm going to do that last. So taking the arctangent of both sides, so arctan or tangent inverse, doesn't matter, of y is equal to, and then this is undone, sorry, that's my dog whining, 0, equals 2x minus 1, and then I'm going to add 1 and divide both sides by 2. So 1 plus arctangent y is equal to 2x, then divide both sides by 2. So x equals 1/2 plus 1/2 arctangent y, or you could do the whole quantity, 1 plus arctangent y all over 2. For these next, For these next few, again, we are solving, but here we don't need to solve for x in terms of y. We're just going to be solving for x. Again, I'm going to go through the process of undoing whatever is being done to the x, kind of going through the order of operations backwards to isolate the x. So this one I have 6 times arc cosine of x. Before I get rid of the arc cosine, I need to get rid of that 6. So I'm going to divide both sides by 6 and have arc, arc cosine of x is equal to 5 pi over 6. And then to undo the arc cosine, I need to take the cosine of both sides of the equation. So cosine of arc cosine, that cancels out. We just have x. And then over here, I have cosine of 5 pi over 6, okay, which hopefully by now we're getting pretty familiar with these. Cosine of 5 pi over 6. Well, 5 pi over 6 would be over here with a reference angle of pi over 6. So 1 root 3, 2 is our special right triangle. And so cosine of this is root 3 over 2, but actually that's a negative. Cosine is negative in quadrant 2 because this x coordinate is negative. So that is equal to negative root 3 over 2. Okay. Next one, I'm going to start by multiplying both sides by 5/3, which is the same thing as dividing by 3/5. I'm going to multiply by 5/3 to cancel this out, but I do that on both sides. So then I have tangent, let me move over a little bit, tangent inverse of x over 2 is equal to 5 pi over 3, okay? To undo the inverse tangent, I'm going to take the tangent of the whole equation, tangent of tangent inverse, that cancels out. So we're left with x over 2 equals tangent of 5 pi over 3, okay? Tangent of 5 pi over 3, let's draw a triangle. 5 pi over 3 is just 1 pi over 3 short of being, of being a full rotation. So 3 pi over 3, 4 pi over 3, 5 pi over 3, okay, which is 60 degrees. So my triangle is going to be 1, negative root 3, and 2. So then the tangent of that angle is negative root 3 over 1, or negative root 3. Okay, and then to isolate the x, I need to multiply both sides of the equation by 2, and I get x equals negative 2 root 3. I'm sorry, my dog is whining again. For number 3 here, I have an arc sine on the left side, and I have an arc cosecant on the right side. I would prefer to deal in terms of sine rather than cosecant because I'm a little more familiar with that. I know that cosecant is the reciprocal of sine. So I'm going to change the right side. Now, remember that it is the ratio that gets flipped upside down for reciprocal functions, not the angle that gets flipped upside down. So this is not equal to, don't write this down, this is not equal to 1 over arc sine of 5/3, okay? Because if you remember, into an inverse or an arc trig function, the input is a ratio and the output is an angle. So this is equal to arc sine of the reciprocal of that ratio, which is 3/5. Okay, so now I have arc sine of x equals arc sine of 3/5. Take the sine of both sides of that equation, and the arc sines cancel out, so we get x equals 3/5. Okay. And then same kind of deal over here. I'm more comfortable with a tangent than I am cotangent. So I'm going to start by flipping the ratio over. Now, x is my ratio because it's the input into the inverse trig function. X is the same thing as x over 1. So then this, come over here to the right side, is equal to tangent inverse of the reciprocal of x over 1, which is 1 over x. Okay, so now I'm going to take the tangent of both sides of this equation. The tangent inverses get canceled, and I have 4/3 equals 1 over x. So then now I can do this in 2 steps or 1 step. If I'm going to do it in 2 steps, I'm going to multiply both sides by 3x. So then I get 4x equals 3, and then I divide by 4. Or I can just recognize 1 over x just means the reciprocal. So 4/3 equals 1 over x. Let's just flip this both fractions upside down. So x is equal to 3/4. Okay, which also tells me that back here I could have left the x where it was, and I could have written this as arc cotangent of 3/4, and then the inverse cotangents would cancel each other, or not cancel each other out, but they would both be undone when I take the cotangent of both sides, and I would have x equals 3/4. Either way, we still get to the same answer. Okay. For these last two, again, we are solving when it says for exact solutions. That means 1, we're not using a calculator, and 2, we're not going to leave something as sine of whatever or cosine or tangent of whatever. We need to actually evaluate those. Okay. So I have sine inverse of x plus tangent inverse of √3 equals 2 pi over 3. Well, this one right here, I recognize there's no variable here, so I should be able to evaluate this. Let's write this as a fraction, just because a ratio, it's easier to see that it's a ratio if I write it as a fraction. So tangent inverse of √3 over 1, well, I can actually figure out what that is. If tangent, this is saying the tangent of some angle, I'll just call it theta, is equal to √3 over 1, then that means I have a √3 here, a 1 here. That means a 2 there on the hypotenuse. And then that is a 30, 60, 90 triangle with a 30 or pi over 6 up here. And so theta here is pi over 3. Let's see. When it says exact solution, also since it doesn't tell me a degree, we're looking for an exact real number solution. And because there is a 2 pi over 3 in my expression, that tells me I'm in radians and not degrees. Okay, so tangent inverse of √3 over 1 is equal to pi over 3. This piece right here is pi over 3. Now, how do I know that it's quadrant 1 and not quadrant 3? Because tangent's also positive down here. Like, how do I know it's not 4 pi over 3, or why can't it be both? Well, if you remember, think back to limiting the domain of tangent so that it's a one-to-one function. Tangent was one that we limited in quadrants 4 and 1. So in other words, from negative pi over 2 to positive pi over 2. And 4 pi over 3 does not fall in that interval. So that's why I know that it's the pi over 3 positive angle that is the correct value for tangent inverse of √3. Okay, so now I have sine inverse of x, and then I'm going to subtract pi over 3 from both sides of the equation, equals 2 pi over 3 minus 1 pi over 3 is 1 pi over 3. And then to undo the sine inverse, I'm going to take the sine of the whole equation. Sine of sine inverse is just equal to x, and then is equal to sine of pi over 3, which if we don't know by now, I already have the triangle drawn for that. So sine of pi over 3 is equal to √3 over 2. So x equals √3 over 2. Okay, if you haven't already, I recommend pausing the video, trying one of these, or trying this last one, and then resume to see if you get the same thing. Okay, so I'm looking at this expression first, the arc sine of √3 over 2, because that is something I can evaluate. That is saying sine of what angle is √3 over 2. So ask yourself that question. This ratio, so the sine ratio of what unknown angle, let's just say theta, is √3 over 2, and then figure out what theta is. Okay, so that whole thing's going to be theta. Drawing a triangle. Again, since this is a positive value, I'm drawing it in quadrant 1. So theta goes here. Okay, so √3 over 2 means opposite over hypotenuse. Okay, so my adjacent is 1. Once again, we have, actually it's the same triangle, so we have a pi over 3 pi over 3 angle there, okay? So now I have arc cosine of x plus 2 pi over 3 equals 1 pi over 3. Arc cosine plus 2 pi over 3 equals 1 pi over 3, okay? I'm going to subtract 2 pi over 3 from both sides, so now I have arc cosine of, oh, I forgot my x. Whoops, back up. Okay, x. So arc cosine of x equals negative 1 pi over 3, or negative pi over 3. And then once again, to undo arc cosine, I'm going to take the cosine of the whole thing. Cosine of arc cosine cancel each other out, so we get x equals cosine of negative pi over 3. Cosine of negative pi over 3 would be the same thing, but down here in quadrant 4. Cosine is equal to 1/2, and if we're going the negative direction, we're in quadrant 4. Cosine is positive in quadrant 4, so I still have a ratio of 1/2.